today we're going to look at Chapter 7. We're going to look at the normal distribution. Last time we looked at probability distributions, and that was the list of all of the possible things that could happen and their probabilities. It was called a random variable, where you listed all of the possibilities that could happen. But we mentioned two types of random variables, discrete and continuous. Discrete said that there were only a certain number of things that could happen. If you were counting how many people in the room, the possibility may range from 0 to 60, but that's all the possibilities you could have. Continuous, we talked about, was data that was obtained by measuring. And it's when the numbers can take on any value between a specific amount. For continuous variables, we couldn't list a probability distribution because you couldn't list all of the possibilities. If you're measuring heights, you couldn't list all of the possibilities because between 5 foot 1 inch and 5 foot 2 inch are an infinite number of possibilities depending on how good your measurement is. 5 foot 1 3/4, 5 foot 7 and 5 foot 1 7/16, depending on how good your measuring device is. So there's not just a certain number of values, there are an infinite number of values you can have on continuous. So when we look at continuous probabilities, we cannot list all of the possibilities like we did on discrete possibilities. On continuous, what we're going to look at are the normal distributions. And we've looked at normal before, and normal distributions are when the distribution was symmetrical. If we graphed the graph of the distribution, it would look like this. Symmetrical meant that if you folded it in half, it's exactly the same on both sides. The peak was right here in the middle, and in a normal distribution, this amount right here was the mean, the median, and the mode. If it was normal, all three of those were the equal. We know that it was the mode because that's where the most frequencies occurred. It's also the median because half are on each side. But this is going to be the mean, and that's what we're going to be interested in the continuous distribution. Continuous distribution, this number right here, is the mean, the median, the mode. We also talked about in normal distributions. If we had a normal distribution, we said 68% of the data was within the mean plus 1 standard deviation and the mean minus 1 standard deviation. So we knew that 68% of the data fell within 1 standard deviation on each side of the mean. Well, if we knew this right here was 68% of the data, then the other 32% was evenly divided on each side. What's left out of 100% and 68 is 32, and 32 has to be split up, so that meant 16% of the data was on this side, and 16% of the data was on this side, because that has to total all up to 100% of the data. Now, what we are going to be looking at in continuous distributions is we're not going to be able to find the probability of getting one particular number like we did in discrete. In continuous data, there are so many possibilities here, it's hard to find the probability of just one number. We're going to find the probability that you are less than a particular number, or that you are more than one number, or that you are in between two numbers. Now, if that number happened to be 1 standard deviation away from the mean, we would know that 16% were less than this value right here. We would know that 16% were more than this value right here. But we want to be able to find more values than just 1 standard deviation away from the mean. To do probabilities in the normal distribution, we're going to use a table. And this table is in the back of your book, Table E. It is also in the very front of your book. This table is used so often, most books put it on either the front or the back flap. And this table is right here on the front of your textbook. Table E, the standard normal distribution. What this table does is tell you the probability of getting between the mean and any particular value. The probability that you will fall between the mean and a particular number. That's what the table gives you. Well, since it is symmetrical, it does not matter if your x is larger than the mean and you want to know what is the probability you're between the mean and that number. Since it's symmetrical, it also, the table value is the same thing if you wanted over here on this side and you wanted to know the probability that you are between a number that is smaller than the mean and the mean. The table gives you both of these values because it really doesn't matter, since it's symmetrical, whether your x is on the left or the right. But what the table gives you is the probability that you are between the mean and a certain value. The probability that you will fall between the mean and a given x. That is what the table gives you. But we will use this table to find other types of problems, and we're just going to use this table in different ways. Maybe I want to find the probability that you are larger than a particular x that is larger than the mean. I have an x over here that's larger than the mean, and I want to know what is the probability that I'm larger than that value. Well, because the table would give me this part right here. The probability is always 100%. The probability of the entire thing is equal to 1. If you divide it in half, then that says you have to have 0.5 on this side and 0.5 on this side. Because these are symmetrical, half of it's on each side of the median. Well, if we know the table value right here, if this half is 0.5, if we take 0.5 and subtract the table, we'll get this little tail here. So if I want to know the probability that I'm larger than an x, that probability is 0.5 minus the table. This little area right here is called the tail. If we want to know the area of a little tail, we take the probability is 0.5 minus the table value. Well, because these pictures are symmetrical, I could also find the probability of this tail over here. But this time I wouldn't be looking at the probability that you were larger than a particular number. I would be looking at a number that is smaller than the mean, and I would want the probability that I was smaller than that number. But still, it's a tail. Whether the tail is on the left or the right, if you want the probability of a tail, you take 0.5 minus the table value. Now, another probability we can find is if my x is over here smaller than the mean, but I want the probability of everything larger than that number. Because this slice right here is what the table gives me, and this is exactly half of the graph, this probability is 0.5 plus the table value. This slice is what the table always gives you, and we want to add half of the probability to it. Now again, it is symmetrical. So if I have an x that is larger, and I want everything smaller than that x, again, this is the table value. I add a 0.5 to it. And this, either one of these pictures would be 0.5 plus the table. What we have to watch is we can't always say, I want to be greater than a number, I take 0.5 minus the table. Because if my number is larger than the mean, it's 0.5 minus the table. But if my number over here is smaller than the mean and I want every number larger, it's 0.5 plus the table. It's the picture that tells us what to do to find the probability. Now, the other probabilities we can find is if you are in between two particular x's. This one right here is if you were between a given x and the mean. We can also have two x's in our problem. What's the probability I'm in between two particular values? Again, every time we have a picture, we can have the symmetrical picture on the other side. Now, the table value for the column x1 and x2 for the two different values, the table value for the first x would give me this slice right here. The table value for the second x would give me all of this amount. So if I subtract those two, the difference is what I want. So this probability is the table from the second minus the table from the first. This probability is the difference in the two table values. But you always remember to take the largest table minus the smallest table because you have to get a positive probability here. So it didn't matter which one you labeled the first x and the second x. You always take the largest table minus the smallest so that you have a positive probability. Remember, probability can never be negative. Now, the only other possibility we can have is if I have two x's that are on different sides of the mean. And I want to find the probability between these two x's. Then this is the first table value, and this is the second table value. So the probability would be adding the two table values. Now, what we are going to do when we go to find a probability for a continuous, they have to be normally distributed. They have to tell you inside the problem somewhere that this comes from a population that is normally distributed. Then, if we know that it is a normal population, the first step we do to find a probability is find what is called the z-value. And the z-value is the particular x minus the mean over the standard deviation. We did z-values before. It's a way of comparing two different values to a mean. But z is x minus the mean divided by the standard deviation. That is the first step we always do to find a normal probability. The second step we always do is draw a picture. No, I'm sorry. Second step is to look up the table value. When we look on that table E, those are z-values. We will have a z-value, we will look up the z, and it'll give us a table value. I'll show you how to do that table in just a second when we work through a problem. We find the z using the formula. We look that z up on the table and find the table value. Then after we have the table value, then we draw a picture. We have a table value, but the table value is not always the probability we are looking for. We draw a picture and we compare the picture to one of these. If the picture we're looking for is one of the tails, then the picture tells us that the probability is 0.5 minus the table. If the picture we want is everything except a little tail, then the picture tells us the probability we want is 0.5 plus the table. The pictures tell us what to do with the table value. These pictures that I've drawn up here on the board are on page 90 of your student study guide. These pictures right here on page 90 of the Student Study Guide are all drawn here real neatly, and you match the picture for your problem to this page. And then it will tell you what to do. The probability is the table value. The probability is 0.5 minus the table value. The picture tells you what to do to find the probability for that particular problem. So you find the z, you look at the table value, you draw a picture, and then you find the probability by what the picture tells you to do. Okay, the easiest way now is just to start working some of these problems, and I want to work some problems from the textbook. I want to go to page 249 in the textbook. And I want to look at number 54. We're in chapter 7, so this is 7-54 on page 249 of the textbook. So this says the average weight of a bag of pretzels is 16 ounces. Standard deviation of 0.3. Find the probability that a bag of pretzels will contain between 16 and 16.2 ounces. When we read a problem, notice at the top of this exercise set, it says assume the variables are normally distributed. Now on a test, I will have to tell you in each problem that this one is normally distributed. Because if you don't know the population is normally distributed, you can't use this particular probability. So each problem on a test, I'll say these are normally distributed. But this section, instead of saying that in each problem, they type that at the top. If these are normally distributed, what you look for is the mean. The mean here is 16 ounces, and the standard deviation. The key is if they say the word normal, you know these are the 4 steps you're going to go through. And you have to find the mean and the standard deviation. Then there has to be one other number given. And what we're looking for is the probability that we are between. We can't say find the probability of picking a bag and it has exactly 16.2 ounces in it. We can only find the probabilities between certain values. The first step is to find this value. And the z value says to take the x minus the mean over the standard deviation. We know what the mean is, so the other value has to be the x. If mean is 16, then the x for this value is 16.2. So we're going to take 16.2 minus 16 divided by 0.3. Now remember on your calculator you need to go 16.2 minus 16 and hit an equal and then divide by 0.3, or you need to put a parentheses around here. Because you have to tell your calculator to do the subtracting before it divides. Sometimes you might want to write this formula like this. That will remind you that you have to put a parentheses around those numbers to tell your calculator to subtract before it divides. So I'm going to take my calculator and go parentheses 16.2 minus 16, close the parentheses, divided by 0.3. I get 0.66667. I'm always going to round that off to 2 places after the decimal. On z values, we can only have 2 places after the decimal. And it might help you if you write down 0.67. Okay, is the z value okay? The first step is just to take that formula and find the z value. The second step then is to look it up on the table. Like I said, this table is used so much, it's very handy to get to right here at the front of your text. What we're looking here on the front of the text is, notice over here on the far column, it says Z. Here's the Z's we're going to look up. If you don't have a book, you may want to scoot over and look over with somebody else because you need to see how to work this table. Under the Z values, you see they start with 0, 0.1, 0.5. Since our number is 0.67, we're going to look down here until we find 0.6. Look down this very first column till you find 0.6. But now, we found the 0.6. Now we have to find the 7. Across the top of this table are listed the hundredths. Here's 0, 100th, 200th. I had a 7 in the hundredths position. So I'm going to go down here till I have the 0.6, and I'm going to move across to the 700ths place. 0.6, and I move across to the 700ths, and that number is 0.2486. The table value is 0.2486. I hope I was reading it upside down. Let me see. Everybody find that on your table. But you have to find the first number after the decimal, and then you move over to the column that is the second number after the decimal. That's the reason we had to round it up, and because the number was 6666, I rounded it up to 67. We can only have 2 decimal places on the Z. Okay, we found the Z, we found the table. The third step is to draw the picture. And the picture always starts off with a normal distribution because we were told these are normally distributed. You always have to place the mean first. The mean, you know where that goes. The mean is the hump right here, so you have to put the 16 here. You always start the picture by putting the mean on there. Now my other value was a 16.2. I have to decide, does that go to the left or to the right? Since 16.2 is larger, I put 16.2 on this side. But you have to put the mean first, so know where to put the other number in relation to the mean. It's larger, it goes to the right. Now the probability I'm looking for is the probability that I was between 16 and 16.2. And I color that in. Because that's what I want, the probability I'm between those two numbers. Now after we have this picture, we either look on page 90 or we look over here on the board and we find a picture that looks like this. And that picture was the first picture I drew between the mean and the x. And that says that the probability is the table value. Probability is equal to the table value for this particular picture. So here the probability is equal to 2486. Okay, is that problem okay? Okay, the next problem I want to look at is number 56 on the same page. Number 56 says the Speedmaster automobile gets an average of 22 miles per gallon. The standard deviation is 3. This is what we always have to find. We always have to know the average and the standard deviation. Then we look for what probability we want. The average and the standard deviation. Find the probability on any given day it will get more than 26 miles per gallon. I want the probability that it gets more than 26 miles per gallon. Again, notice on these you cannot find the probability you get exactly 26. It can be less than 26, more than 26, between 26 and another number. This time it's more than 26. So the first step is to find z. And z is always x minus the mean over the standard deviation. Again, if it helps, write the parentheses down on the formula to remind yourself you have to tell the calculator how to calculate. Okay. Now the table value. Table value. Again, we start looking down this column here for the z's, but this time we have a 1.3, so we move down till we find 1.3. It's 1.33, so I move over to the column 4082. Can everybody find that on the table? Okay. Third step is always to draw the picture. You always start with the mean. The mean was 22. You have to put the mean on there first because you don't know where to put the other number. Then once you put the mean, my other number this time is a 26. If it's larger, I put 26 to the right. More than 26 says I want everything that is larger than the 26. Again, you either look at page 90 or come over here and look at these tables. You look at these tables because I have a little tail colored in. This is called a tail. This says the probability is 0.5 minus the table. So this time the probability is 0.5 minus 4082. .0918. Okay, let's try 58. '58 says a recent survey conducted by a television magazine found that the average person watched 18.6 hours of television per week. The average person watches 18.6 hours of television, standard deviation 2.3. The A part here says find a probability that the person watched less than 15 hours. Find the probability that the person watched less than 15 hours. First step again is to find the Z. X is 15. Remember to make sure that it's always the mean that is being subtracted. It's going to be important later on that we don't get these two numbers backwards. You're always subtracting the mean. Because it was 1.565, I round it up to 5/7. If the number is 5 or more, you round it up. Now this is a negative. The z is negative, but when I go to look up the table value is always positive. It doesn't matter whether you have a positive or a negative z. The table value is always a positive number. So 1.5, on the table you go down to 1.5 over to the 7 column. Did you find that on the table? 1.5 over to the 7. Again, we draw the picture. And the picture always starts with the mean. So you put the mean on, you don't know where to place the other number. The other number is a 15. If I want less than 15, less than 15 and the number's smaller, so I go to the left. Now look at the graphs and tell me, what does this problem tell me to do to find the probability? It says to take 0.5 minus the table. Find that particular picture, and that picture says 0.5 minus the table. So I'm going to check my subtraction. But it's always the picture that tells us what to do. Okay, on this problem, what did the B tell you to find? The B says more than 22. Again, the first step is to find Z. 22 minus the mean over the standard deviation. Remember to round up if that third number is 5 or more. So I get 1.48. The table value for 1.48. You go down the column 1.4, you move over to the 8.4306. Draw the picture. Key thing to remember about the picture is you always have to put the mean on first. Then you know that since our other number is 22, 22 is larger, it goes on this end. And if I want more than 22, what does this picture tell me to do? It says 0.5 minus the table. Now, what this problem here, number 58, shows is that we had a problem that said more than, and we also said a problem that said less than, but they both ended up being the probability is 0.5 minus the table. You can't always say more than tells you to subtract, because this problem was more than and we subtracted, but this problem was less than and we subtracted. It's the picture that tells you what to do. It's the different pictures that tell you how you're going to find the probability. Okay, now look down at 60. Number 60 says in a recent survey, the average age of CEOs was found to be 56. The standard deviation was 4. So we know the average and the standard deviation. If a CEO is selected at random, find the probability that it's between 53 and 59. So this is the probability I'm looking for. I'm between 53 and 59. First step is always to find the z, but this time my mean is 56. I have two different numbers, so I have to find two different z values. I'm just going to label them z1 and z2 anyway to keep them straight. But if there are two different numbers here, I have to find two different z's. And the first one, I'll have to take 53 minus 56 over 4. The next one, I'll have to take 59 minus 56 over 4. Now this time the two z's happen to be the same number, but they won't always be the same number. You'll find two different z's. Is that right? So if you have two different z's, you have to look it up and find two different table values. Table 1 and Table 2. So you look under the 0.7, 0.7, and move over to the 5 column. Because they were the same, these are both going to be the same number. But like I said, these z's will not always be the same. You may have two different table values here. We draw the picture. And the picture always starts with the mean in the middle. The mean was 56. You have to put the mean to know where to put the other numbers. Then 53 is smaller, but 59 is larger, and we want between 53 and 59. But if we didn't have the mean in the right position, we wouldn't know where to position these two. So the mean is always the key point here. Now I look at the picture. This set of pictures is this graph right here. I've colored in two X's with a mean in between. This picture says take the table and add the other table. So the probability is 2734 plus 2734. The key to these is the picture is always telling you what to do. What does the B problem here tell you to find? Between 50? Between 58 and 63. Again, the two Z values. Z value for 58. And the Z value for 63. two different table values. .5 1.7, and then over to the 5 column. Okay. Draw our picture. The mean was 56. The mean has to go on there first. That's our reference point. The mean is 56, 58, and 63. Between 58 and 63 is just this one tiny slice. So look over those pictures and tell us what those tell us to do. It says to take and subtract those two table values, but if I've got them numbered differently in the book, what you've always got to remember is you must take the larger minus the smaller. You may have numbered it differently, but it's always got to be the larger number minus the smaller number, because you have to have a positive probability. So I'm going to take 4599 minus 1915. You get a negative probability, that is always wrong. So you must take the larger minus the smaller to get the probability. So we can see here that we have to be able to find Z, look it up on the table, but the key is drawing the picture. If you don't draw the picture, you don't know what to do with that table value to find the probability. Now I'm not going to work the number C here because they're all the same method. Once you get down these 4 steps, all of these problems are the same. But I do want to look over on the next page on number 70. I read through number 70, and it says, in order to qualify for a letter sorter, the applicants are given a speed reading test. The scores are normally distributed with a mean of 80 and a standard deviation of 8. Okay, so far this looks like our typical problem. They give you the mean, they give you the standard deviation. But then it says if only the top 15% are selected, find the cutoff score. They tell me the top 15%. If they give you a percent, this is like giving you the probability. This particular problem gives you the probability. 15% says that the probability is 0.15, and they're asking for the cutoff score. The cutoff score, or the score, says they want you to find the X. This is going to be backwards from the other problems. The other problems were finding the probability. Well, this time they told us the probability, but we have to work backwards to find the X. If we have to work a problem backwards, when we know it's backwards, is if they give us the probability and we're supposed to find X. X is when they ask for the cutoff, the score. To work backwards, the first thing we have to do is draw the picture. We draw the picture. We always know that the mean was going to be here. Now, if I want the top 15%, That means there's going to be a particular score, and I want everything above that score. Well, there's two possibilities. I could have an X on the left, and I had everything above that score. Or I could have an X on the right and have everything above that score. To decide what my picture looks like, I usually draw two pictures. If I want the top, I know it's going to be everybody above a certain score. The top tells me to be above a certain score. But there's two possibilities here. But if I only want 15%, which one of these pictures would represent 15%? This one will represent 15. This is way too much to be just 15%. It's over half of the picture. But I draw two pictures to see that I want above a certain X. The top told me I want all the numbers above a certain X. But only one of the pictures could possibly represent the top 15%. But sometimes if you draw both possibilities, it's easy to see which one is the one you want. Once I draw the picture, then I look at those pictures to see what was the probability equal to. For this particular picture, compare this picture to the graphs. The probability was equal to what? The probability was 0.5 minus the table value. Well, this time we know what the probability was. We know that the probability was 0.15. This time we're going to solve for the table value. But again, it's those pictures that told us what to do. We know the probability. We can solve for the table. If I subtract 0.5 from both sides, I get a negative 3.5 equals to a negative table. Multiply both sides times the negative 1. So the table is equal to 0.35. This time we knew the probability, so it was the table value we had to solve for. Now we found the table value. Now we go to the table and find Z. This time when we are looking, we've got to remember that we are looking for a Z. Don't look down this column because I don't know Z. This column over here is the Z. We don't look over here because we don't know Z. If we know the table value, we look inside the table. Don't look down this side. Look inside the middle of the table. It's going to take a while to read through those numbers and find over here in the table the closest one to 3.5. 3485, 3508. 3485 is 15 away. 3508 is the closest. 0.3508 is the closest. Did y'all find that in the middle of the table? So now I go over to the side and see that that was 1.0 and under the 4 column. So Z is 1.04. Now the most common mistake is trying to read it here. But we know the table, we have to look inside the table to find the Z. Now at this point, remember the table was always positive, but Z could be positive or negative. And we have to know whether to stick a positive or a negative on the Z. To do that, you look at your picture again. If your X is to the right of the mean, you put a positive on there. But if your X is to the left of the mean, you have to put a negative on here. If you don't stop at this point, you're going to miss half of them because you'll always leave it positive. But sometimes you have to put a negative. And you look back here at the picture. X is to the right, it is a positive. So we do leave this positive 1.04. But if you don't take the time to look at the picture, when it should be a negative, you'll leave it positive. But if X is on the right, you put a positive on it. If X is on the left, you have to put the negative. The picture is the only way to know whether it's positive or negative. Now, the last step is to figure out what Z is. We know Z, we're trying to look for X. We use Z equals X minus the mean over the standard deviation. We're looking for X this time. What was the Z value? We found the Z was 1.04. We don't know X. We know the mean and the standard deviation. Everything is backwards. We go to this formula last to solve it for the X. In algebra, when we have an equation with a fraction, the first thing you want to do is multiply both sides times that fraction to cancel it out. Multiply both sides of the equation times the denominator, and then add 80 to both sides. If the average score is 80, anybody that makes an 88 is going to be in the top 15%. So you only want people that make 88 or above, and you'll have the top 15%. But this problem was worked backwards, and the backward ones are a little bit more complicated. Okay? It's okay on the backward ones. Let's look at number 80. Number 80 says a pet shop owner decides to sell tropical fish that will appeal to the middle 60% of the customers. The owner reads a study that says that the mean price is $9.52. Standard deviation of 1.02. She wants to sell tropical fish that will appeal to the middle 60%. Find the maximum and the minimum price. The first step is still to draw the picture. When we work backwards, the picture is the first step. I know where the mean belongs, but if I want the middle 60%, the middle 60% says I'm going to have to draw a line on both sides and find two different x's. The middle 60%. But if you want the middle 60%, if all of this is 60%, then that means you want 30% on each side. Now, even though we have a picture that is like this, we have a picture that is between two x's. If you are looking for two x's, it is easier to divide this up into two pictures. Is it easier to work it as two separate problems? That says you want between the mix, between the mean, and one of the x's. And you also want to find the mean to the second x. Even though this is the picture we want, it is easier to work it as two separate problems if you're looking for two separate x's. And because this was 60%, this one has got to be 30%, and this one has got to be 30%. If you'd have wanted the middle 80, you'd have put 40 in each side. You divide it in each two pieces. But if you're looking for two x's, it's easy to work it as two completely separate problems. So the next step is to look at each one of these pictures and see what is the probability. For this picture, the probability is the table value. When you find that picture over there, it says the probability is the table value. So for this one, the probability is the table value. For this one, the probability is the table value. What you know is 0.3 is the table value. The probability is 0.3, so 0.3 is the table value. Find the z that goes with 0.3. Again, we start in the middle. Because you have the table, you start in the middle, the closest number to a 0.3. The closest number to a 0.3, I have 2995 and 3023. Which one is actually closer? This one's actually closer. It doesn't matter whether it's above or below, we want the one that's actually closer. 2995 is the closer, and it's 0.84. On both of these, the z is 0.84. But I look at the picture and I decide, do I put a negative or do I put a positive on it? On this picture right here, x is to the left. If x is to the left, you have to put a negative on it. But for this picture, x is to the right, you put a positive on it. So even though they had the same table value, the picture gives me different z's. One is a positive z, one is a negative z. Now I put these back into the formula. Z equals x minus the mean. The mean is 9.52 over the standard deviation. And I first put a negative 8.4. But I'm going to have to work this problem twice. One for a positive, one for a negative. The first step is to multiply both sides times 102. Then add 9.52. And because this is dollars, I'm going to round it off to 2 decimal places. Talking about money, you don't leave 4 decimal places here. Again, I'm going to multiply times 102. And add 952. we might say here the